Now, let us discuss in detail surface area of a right circular cone. We have come across solids such as ice cream, birthday caps, funnels, traffic cone, etc. Let us see how to measure them in terms of surface areas. Here, we see that there are only two surfaces for this cone. One is the curved surface and the other one is the circular base. Now, let us take a point at the vertex of this cone and name it as A, and a point B on the circular base and C on the slant surface of the cone. When we join these points, we get a right-angled triangle. Side BC is the radius of the circular base given as R, AC is the slant height given as L, and AB is the height of the circular cone given as H. Here, we see the longest side is the slant height, which is the hypotenuse of the right-angled triangle. Therefore, we can use the Pythagoras theorem to find the relationship between these sides, which is given by L square is equal to the sum of R square and H square. Therefore, L is equal to the root of R square plus H square. Now, cut out a neatly made paper cone that does not have any overlap paper straight along its side and opening it out to see the shape of paper that forms the surface of the cone. The line along which you cut the cone is the slant height of the cone, which is represented by L. It looks like a part of a round cake. If you now bring the sides marked A and B at the tips together, you can see that the curved portion will form the circular base of the cone. If the paper is now cut into hundreds of little pieces along the lines drawn from the point O, each cut portion is almost a small triangle, whose height is the slant height L of the cone, and B1, B2, B3 are the bases of the triangles respectively. Therefore, the area of each triangle is given by half multiplied by base of each triangle into the length, which is equal to the sum of the areas of all the triangles. That is, area of each triangle is equal to half into base of each triangle into L. So giving you the sum of the areas of all the triangle, that is half B1L plus half B2L plus half B3L, which goes and so on. That is, you take common half L in brackets B1 plus B2 plus B3, and it goes on. That is half into L into length of entire curved boundary in the figure. That is 1 by 2 into L into the base of the cone, which is equal to half into L into 2 pi r, giving you pi rl. Therefore, the curved surface area of the cone is pi rl. Now, let us calculate the total surface area of the cone. That is, we add both the areas of the circular base and the curved surface of the cone. Area of the circular base is given by pi r square and the curved surface area of the cone is pi rl. Adding both, we get pi r square plus pi rl. Taking pi r as common, we get pi r multiplied by r plus l. Therefore, the total surface of the cone is given by pi r into r plus l. Let us now consider a problem. Curved surface area of a cone is 308 cm square and its slant height is 14 cm. Now let us find the radius of the base and total surface area of the cone. The solution for the same is as follows. The curved surface area of the cone is given as 308 cm square from the problem, and the slant height L is 14 cm. So the first subpart is to find the radius of the base. That is pi rl is equal to 308 cm square. Plugging in the values, we get 22 divided by 7 into r into 14 is equal to 308. Solving for r, we get r is equal to 7 cm. Now the second subpart, total surface area of the cone. So let us take the formula, that is pi r into r plus l. Plugging in the values, we get 22 divided by 7 into 7 in brackets 7 plus 14. Solving for the same, we get 22 into 21, which is giving you 462 centimeters square. Now, Let us consider another problem. What length of tarpaulin 3 meter wide will be required to make conical tent of height 8 meter and base radius 6 meter? Assume that the extra length of material that will be required for stitching margins and wastage in cutting is approximately 20 centimeter. Here we can use pi as 3.14. Solution for the same is as follows. So from the problem, we identify that height of the tent is given as h, which is equal to 8 meter, and the base radius is r, which is equal to 6 meter. So we can find the slant height by L is equal to root of r square plus h square, which is equal to 10 meter. Now the curved surface area of the cone is given by pi rl. Substituting the values, we get 3.14 into 6 into 10 meter square, which is equal to 188.4 meter square. Therefore, length of 3 meter wide tarpaulin required is equal to 188.4 meter square divided by 3 meter, giving you 62.8 meter. Now, the extra length required is 20 centimeter. So, converting the same into meter, we get 20 divided by 100, which is equal to 0.2 meter. Therefore, the total length required is 62.8 plus 0.2, which is equal to 63 meter. Now, let's summarize. Curved surface area of a cone is given by pi rl. Total surface area of the cone is given by pi r multiplied by r plus l. And slant height of the cone is given by L is equal to root of r square plus h square.